Choose one.
Okay, time for transformation. So learning moment 3. Where are we? Learning moment 3. So when it comes to this situation, we're going to bring in, we already brought in the data, great, fantastic. But I'm going to pretend, or we're going to pretend as if we didn't already have a column named name in the actual column for each player. What I mean by that is that each person or each sheet has their name. What we're going to do is add the player's name to each data frame. Okay, just so that, just in case, you know, it's practice. It's good practice when you're going to combine them in some way, shape, or form. So when it comes to Michael Jordan, we can sit there and say this is Michael Jordan. Okay, Jordan. LeBron James is with a capital B. Okay, LeBron James, and then finally, we go ahead and add the following Kobe Bryant, the late Kobe Bryant, by the way, Bryant. Okay, so then we can go ahead and run this, but I'm gonna comment this out because I want to make a statement about this. Run these 3, and then when I go here, I'm going to notice that I have a new column, and it's imperative. It's really imperative that you, every single time you make a transformation, you check that it worked. Okay, so there's a player Kobe, player LeBron James, player Michael Jordan. Okay, great, fantastic. So we exit out all these, but these are in different data frames. Okay, they're in different data frames. Ideally, we would want to put them on top of one another. Okay, and so the function that allows us to do this is called, drum roll please, bind rows. Bind rows. So if we utilize this functionality called bind rows, we're able to then put them on top of one another because we want to have the same column. We have the same columns throughout each of the data frames so that we have one data frame with the same columns across each situation. So when we run this, boop, okay, you have this new data frame, NBA rows. You see the corresponding column that has all the players' names. It should have another identifier as well. And if you notice here, in terms of this, we have 1156 in terms of number of rows, 1214, 1030. Okay, it's the number of rows for each one, and we're then combining all of them to be now 3400. Notice the number of columns is consistent throughout. Okay, the number of columns is consistent throughout. That's that. Some other important things to even mention in terms of this is there's so many indicators on what's happening in terms of our data, whether it's right here, we can view it here. I did a glimpse as our function, so we can see the glimpse of all the data that we've now brought in, or at least now that we've brought together, and that's that. There are other ways of binding data, or at least there's another way of binding the data, and that's bind calls. And so if there's 2 data frames, you can combine them horizontally. That's traditionally not an ideal technique. I have done it before. I've had use cases to use bind calls, but that assumes that the rows are the same. So like in data frame 1 versus data frame 2, they're the same rows across all rows. And that rarely does happen. And so what we tend to do is join, like to match based on, you know, some type of identification. You'll see that in the other videos, the LFM videos. But in this situation, since we don't have a need for it, we're not going to display it. Okay. So one more thing to note in terms of binding by rows, we make them vertical. If there wasn't a match, if there was a column that was in Kobe Bryant's data frame, but not in LeBron James and not in Michael Jordan, it would just create that column and then just have NAs. It would just have NAs. Okay. So be aware of that. So let's answer some of these questions. So what does bind row do? You can use it in your own words, but I would say it bind rows stacks data frames vertically, appending rows of the second and third data frames, okay, below the first. So we could have had multiple. We could have had more than just these 3 players, but technically we only have those 2 players from our Excel sheet. But I could have rewritten this as MJ and then Pipe. That would work the same way. So just note that that's fine as well. What happens? I just addressed this. What happens if the column names do not match perfectly when using bind columns? Bind rows. Bind rows performs a union of all columns if a column does not exist in one data frame but another in another. The missing entries are filled with an A. Okay, so that is what happens. So let's have another learning moment, I believe. And it's about rename. Okay, let's say we want to change the names of our variables. And how we would do this is just utilizing this function called rename. So select, let's say we select 3 variables player. Okay, just for fun. Then we select season. And why did we select these variables? Just because I'm just trying to illustrate, working with our data. Then we have PTS, okay, points. We can then just rename points as the following. Because let's say you don't know what PTS is, but you look at the abbreviation, documentation, and now you know what it is, and now it works. So you have PTG, or points PG, rather than PTS, okay? So what does rename do? Okay, it changes only the column labels. It changes only the column labels, the name by which you reference the column in the code. The name by which you reference the columns in the code. You could do multiple renames at once, by the way. Okay, just so you know that for your own benefit. All right. So that is learning moment 4, but learning moment 5 is a little bit more important. Okay, so I'm just going to take one step back and just look at the clean DF, right? This data frame right here. It has our variables, but notice a couple things. Season, I'm going to relabel season, and I'm just going to mess me up later, but it's fine. I'm going to say season is just season, because of uppercase. I could have done this in a lot of different ways, but this is one of the ways that, it's pretty straightforward. Just so that we have all the same case. What we want to do is determine if a game, right, is within the very first 5 seasons. We want to say that's when the player was novice. The second 5 seasons, 6 to 10, is intermediate, and then 11 to 15, we're going to say that season, that time is veteran. And the reason why we want to do this is because to answer subtask 2, we want to see how they perform across these different seasons, across their time. And I don't want to look at all 15 variables in terms of my visualization. So we're going to relabel these seasons, okay? So you see, this is the logic, this is the data. Let's go to R and make this specification, okay? This is not correct. We saw season is actually labeled by season 1 through 15 in this format. And so let's change it accordingly. So one of the first things to note is this function right here. It's called string extract. This string extract is going to extract a number. It's going to extract a number from this string. Okay, it's going to extract a number. So and I gotta make this lowercase season. It's going to extract a number. Once it extracts the number, I'm going to turn it into an integer. That's what this as integer is doing. Okay, that's what that as to integer is doing. And then I'm going to save that information into a variable called season num. Okay. And then what I'm going to do with season num is say if it's less than or equal to 5, like I said, 1 through 5, is going to be labeled as, in double quotes, it's going to be novice. If it's, once that's labeled, all the 1 through 5s are gone. What's left is above 6. All right, so 6 through 15. So now if it's less than 10, less than or equal to 10, I'm going to say intermediate. And once I do this, the only thing that's left over is any value that's above 10. Intermediate. I think I spelled that right. Intermediate, yeah. Okay. Intermediate, and then so then anything above 10 is then labeled as expert level or veteran. Veteran. Okay, so that's that's that. And so that's the specification. So if I run this, I can't run it yet, but that's now experience. Now I want to set experience as a factor. What that means is that it's no longer going to be treated as a string. It's going to be treated just as a special group. And this is the ordering of the group. As in, this is going to be novice. This is going to be then intermediate. Intermediate. And then this is finally going to be veteran. Veteran. Okay. So now I'm going to ungroup the information so it's no longer grouped together. Actually, I don't know if I need that still, but let's just run it. String extract. Okay. It says that string extract does not exist. Uh-oh, what do we do? That tells me that I did not load the package that string extract comes from. And that comes from library string R. Okay, library string R. So that's my apologies. If you did install library tidyverse, you don't have to install this. But I'm going to then place it here. And since I already have it, I don't have to install it here as well. But I'm going to call this data transformation string manipulation. Okay, string manipulation. So run this. And then now when I make that change, it should work. Okay. It should be num. It should work. And so now if I were to do, this is not in my notes, but if I were to do a table of NBA underscore clean, I'm gonna do $sign. That allows me to extract the actual player information real easy. So I'll do $sign season number, and then I'll do NBA clean $sign experience. What I want to do is check if there is a match, right? And so what it's saying is that seasons 1 through 5 is novice, seasons 6 through 10 is intermediate, and seasons 11 through 15 is veteran. So we got what we want. Okay, so we got what we want. Something that I didn't get to emphasize, because a lot of different moving pieces here, is case 1. So case 1 allows me to subjugate the case based on a certain condition. So I'm able to subjugate this case when season is less than or equal to 5 as novice, intermediate when it's less than or equal to 10, and then the rest is going to be veteran. Okay, so how would you articulate that? So you would say case when evaluates a sequence of logical conditions in order, it needs to be in order, and returns the value attached to the first condition that is true for each row. So it says on season number, based on season number, what is it? If it's less than 5, it's novice. It's less than or equal to 5, it's true, so therefore it's novice. Else it's false. Okay. And so then it does the same check for the next logical statement. If it's less than or equal to 10, okay, let's say it's again 6, let's say it's 6, it's going to label it as intermediate. But if it was greater than 10, it's going to say, oh, it's false. And then once it's specified as intermediate, let's say if it's a new season, a new row is 11, it would have already passed these, it would have been labeled as false, and it's just going to change it to true and then label it as veteran. There's other ways of specifying this. We could have just done season less than or equal to, or in between 1 and 5, season number in between 6 and 10, and season number in between 11 and 15. But let's say, for example, new data came in and it was season 16, and so this is a way for us to at least cover all our bases in terms of the conditions that are possible. Okay, so that is that. This is actually a nice situation because we actually did this so that it can specify the logic of the levels. So we want to specify that novice is less than intermediate is less than veteran. So in answering this question, the reason why we even specify it as a factor is so that it's not treated as an alphabetical order. So it's not set in alphabetical order. It's set on logic of novice, intermediate, veteran. So let's actually write that down. So by default, the char character vectors plot in alphabetical order. I and V, right? Intermediate, novice, veteran. But if we set the levels, we can automatically make the order based on logic. Okay, based the logic on order. Based the order on logic, sorry. So that's that. Okay, so this is so for us to be able to answer sub task 2. All right, so let's continue. So now we're going to do a little bit of a group. We're going to do a group by points. We've done this before, but it's nice just to see it again. Okay, just to see it again. In terms of grouping by in this situation, we're going to group by player to be able to, figure out the average points, the standard deviation of points, and the frequency. So we're going to do player. We're going to find the mean of the points. I think we called it, what do we call it? Points PG. We're going to find the standard deviation. We're going to use SD here. Okay, that's the function for standard deviation. And then ideally, hopefully you remember from the previous transformation, we're going to use N as our transformation. And then last but not least, we're going to arrange it by career average points. Okay, career average points from smallest to largest. Okay, so we can actually see this. Okay, from smallest to largest, that's good. So we have average points. You see, Michael Jordan is the greatest. Why are you that? and he's, well, LeBron's more consistent in his first 15 seasons, but whatever. But you can see the number of games, you can see per player, you can see the standard deviations, and so on and so forth. And the reason why we even did this is so that we can actually, we're going to use this in the visualization phase of the video, of the component. So take note of that. One thing to note is that this line, so we can get better practice, arrange sorts the rows of the data frame by one or more columns. What that is even saying is that after I arrange it by career, I can also then arrange the following groups by another variable as well, which is fine. But then we are sorting it descending, so it goes from the largest to the smallest. We didn't have to write this in, but I traditionally always try my best to always write this in. It was already there for us. But what this means is that if there's any missing values, it removes it from the analysis so that the actual average can be created. Meaning that if we didn't have these values and there's the NA that's present, we're essentially getting NA in our results. Let me see if, I don't know if this is, I think we have data for everybody. Let's see. You see, so Kobe and Bryant and LeBron James did miss some days. So that's why we actually include that NA removed so that the average can be calculated, remove those missing values. Oh no, my lights went out. Okay, I'm back. Okay, so 23 minutes. Uh-oh. So finally, what does the NA that removed do? If any season, or I should say season player, any season our player, if any player, that's what it should be. If any player has missing values, NAs, the mean, the argument will remove those values. Okay, that's fine. With NA.remove is equal to true. Okay, so that is transformation. Thank you so much.